Have you ever looked up at the night sky and felt a spark of wonder? Those distant stars have captivated humans for thousands of years, inspiring curiosity, exploration, and imagination. From ancient stargazers tracking the seasons to modern telescopes revealing distant galaxies, we've always wanted to know what's out there. That same curiosity eventually led to rockets, orbiters, and astronauts venturing into space. Today, we're closer than ever to reaching other worlds, exploring planets, moons, and even thinking about life beyond Earth. This journey through 100 fascinating facts will take you from our earliest observations of the cosmos to the cutting-edge science shaping humanity's future among the stars. Fact 1. Humanity's fascination with the stars. Imagine looking up at the night sky for the first time and seeing 1,000 tiny lights twinkling in the darkness. That feeling of wonder hasn't changed for thousands of years. Humanity's fascination with the stars is almost instinctive. We've always looked up and asked questions. What's out there? Are we alone? Why do the stars move the way they do? Long before telescopes or rockets, people relied on the stars to make sense of the world. Farmers used them to know when to plant crops. Travelers used them as guides through deserts, forests, and seas. And civilizations saw stories in constellations, heroes, monsters, and animals written across the sky. These early interpretations weren't just entertainment, they were ways of understanding life and nature. The stars also sparked curiosity and imagination. Ancient humans noticed patterns. The same stars rose and set at the same times, and some appeared to move differently. This led to early astronomy, which was part science, part spirituality. Many cultures built monuments aligned with celestial events. The pyramids in Egypt, Stonehenge in England, and the Mayan temples in Central America. These weren't just impressive structures, they were reflections of a deep, ongoing conversation between humans and the universe. Even today, that fascination hasn't faded. When we watch a rocket launch or see images from the Hubble Space Telescope, it's a continuation of that same curiosity. The urge to explore, understand, and reach beyond our small world is as old as humanity itself, and in many ways, it's the first spark that eventually led to real space travel. Fact 2. Ancient astronomy and early sky observations. Long before modern science, ancient people were already observing the sky with remarkable precision. Civilizations like the Babylonians, Egyptians, Chinese, and Greeks were tracking the sun, moon, planets, and stars, and they were doing it for very practical reasons. Calendars, agriculture, and navigation all depended on understanding the heavens. The Babylonians, for example, could predict lunar eclipses with impressive accuracy. Ancient Egyptians aligned temples and pyramids with celestial events, especially solstices. The Chinese kept detailed records of comets, supernovas, and planetary motions, many of which we still reference today. Observing the skies was not just a hobby, it was survival. Knowing when the Nile would flood, for instance, could mean the difference between feast and famine. These early astronomers didn't have telescopes or satellites, but they developed systems and tools, like sundials, water clocks, and armillary spheres, to study the sky. They even started thinking in terms of patterns and cycles, the earliest steps toward the mathematics of astronomy. And as they observed, myths naturally emerged to explain what they saw, blending science and story in a way that was deeply human. It's fascinating to think that our ancestors, looking up at the same stars we see today, were laying the foundations for all modern space exploration. Without these early sky watchers, we might never have wondered about travelling beyond Earth. Fact 3. The first telescopes and what they revealed. Fast forward to the early 1600s. Humanity finally invented the telescope. Suddenly the universe came into sharper focus. Galileo Galilei was among the first to point a telescope at the sky, and the discoveries he made were mind-blowing. He saw craters and mountains on the moon, moons orbiting Jupiter, and countless stars invisible to the naked eye. Before this, the universe seemed static and perfect. Galileo's telescope shattered that idea. The moon wasn't a smooth, flawless sphere. It was rugged and alive with detail. Jupiter had its own moons, hinting at the complex systems beyond Earth. Stars were not just points of light, they were distant suns, possibly with their own worlds. The telescope didn't just reveal new objects, it changed humanity's place in the cosmos. It sparked curiosity and controversy alike, challenging long-held beliefs. People began to imagine that if we could see these distant worlds, perhaps one day we could reach them. It was the first real step toward thinking about space travel as more than just a dream. And while Galileo's telescope was simple by today's standards, it was revolutionary. It showed that careful observation and curiosity could reveal truths beyond what anyone imagined, opening the door to centuries of discovery that continue even now. Fact 4. The birth of modern astronomy. Modern astronomy began when observation met mathematics. In the late 1500s and early 1600s, astronomers like Johannes Kepler and Isaac Newton started uncovering the laws that govern celestial motion. Kepler discovered that planets move in elliptical orbits, not perfect circles. Newton later explained why, with his laws of motion and universal gravitation. Suddenly, the sky wasn't a mysterious tapestry. It was a predictable, understandable system. This wasn't just academic. Understanding the forces at work in space meant we could start imagining travel beyond Earth. If planets followed laws, perhaps humans could navigate them too. And as telescopes improved and observatories spread across Europe, the data piled up. Stars, planets, comets, and nebulae became measurable, countable, and understandable. Modern astronomy also brought the idea that Earth was not the centre of the universe. The Copernican revolution placed the Sun at the centre of the solar system, changing our worldview forever. Humanity realised that our planet is just one small part of an immense cosmos. That realisation is what fuels space exploration even today. The desire to see, measure, and eventually visit what seems impossibly far away. Fact 5. The concept of space travel in myths and fiction. Long before rockets and spaceships, humans dreamed of travelling to the stars. Myths and legends often included journeys to the heavens or distant worlds. In Greek mythology, heroes flew with wings or rode chariots across the sky. In Chinese folklore, people imagined trips to the moon or immortal realms above the clouds. These stories reflected curiosity, imagination, and the desire to explore beyond the known. By the 19th and 20th centuries, fiction began to shape modern space travel ideas. Writers like Jules Verne and H.G. Wells imagined rockets, lunar voyages, and interplanetary adventures. These weren't just entertaining tales, they inspired scientists and engineers to take those dreams seriously. Without fiction sparking imagination, rockets and space programs might have taken longer to emerge. Even today, science fiction shapes our ideas about Mars missions, space colonies, and the search for extraterrestrial life. Dreams of the stars, rooted in myth and story, eventually became real engineering challenges. Humanity's imagination paved the way for actual space travel, proving that stories can be the first step toward reality. Fact 6. Early rocketry experiments in ancient China. Believe it or not, rockets were first imagined thousands of years ago not as tools for space exploration, but as weapons and fireworks. Ancient China was the birthplace of early rocketry. Around the 12th century, inventors discovered that gunpowder could propel small tubes through the air. These early rockets weren't aimed at the moon. They were used in military battles and festive celebrations. But the principle was the same: a controlled explosion pushing an object forward. Soldiers launched arrows attached to gunpowder tubes, and during festivals, bright rockets streaked across the night sky. While primitive, these experiments showed humans could harness chemical reactions to create motion, laying the groundwork for what would become modern rocketry. Interestingly, the Chinese didn't just fire rockets at random. They began experimenting with stability, shape, and propulsion. They learned that adding fins could keep the rocket from spinning wildly, and that controlling the powder's quantity affected distance and speed. These observations were crude, but the underlying idea was profound, using force to send an object far beyond what humans could physically reach. Centuries later, explorers and engineers would look back on these early experiments as the first real step toward the possibility of space travel. It's amazing to think that fireworks and battlefield weapons centuries ago were the ancestors of rockets that would one day carry humans to orbit. Fact 7. Konstantin Tsiolkovsky and the theory of rocketry. Fast forward to the late 19th and early 20th centuries, and we meet a man whose ideas were decades ahead of his time: Konstantin Tsiolkovsky. A Russian schoolteacher with a passion for space, he didn't just dream of rockets, he calculated what would be needed to actually reach space. Tsiolkovsky's most famous contribution is the rocket equation, which explained how the speed of a rocket depends on the mass of its fuel and the exhaust velocity. In simpler terms, he showed mathematically that reaching orbit was possible if you used the right fuel and design. He also imagined multi-stage rockets that shed parts of themselves along the journey to go farther. This concept is still fundamental to modern spaceflight. He wasn't building rockets in his backyard, though he did tinker with small prototypes. His work was mostly theoretical, published in papers that few people read at the time. But his ideas inspired future engineers and dreamers. Essentially, Tsiolkovsky turned the notion of space travel from imagination into something you could calculate, measure, and eventually achieve. Without his work, sending humans beyond Earth might have remained a fantasy for much longer. Fact 8. Robert Goddard and the first liquid-fueled rocket. If Tsiolkovsky gave the math, Robert Goddard gave the world action. In the early 1920s, this American physicist built and launched the first liquid-fueled rocket. Unlike solid gunpowder rockets, liquid fuel allowed for controlled and sustained thrust, which made longer flights possible. Goddard's first launch in 1926 went just over 50 feet, but it was history in motion. People criticized him at the time, claiming space travel was impossible, yet he persisted. He experimented with gyroscopes for stability, nozzle designs for efficiency, and even considered rockets capable of reaching the moon. His work didn't immediately lead to manned spaceflight, but it laid the engineering foundation. Every modern rocket, from the Saturn V to SpaceX's Falcon 9, relies on principles Goddard pioneered. It's incredible to think that a small launch in a field in Massachusetts would eventually lead to humans walking on the moon. Fact 9. The role of science fiction in inspiring astronauts. It's easy to underestimate the power of a story, but science fiction has played a huge role in space exploration. Writers like Jules Verne, H.G. Wells, and later Arthur C. Clarke imagined rockets, space stations, and journeys to other worlds long before they were technically possible. Astronauts often cite these stories as a source of inspiration. Wernher von Braun, the German-American engineer behind the Saturn V rocket, was influenced by science fiction as a child. The imagination sparked by stories can be just as powerful as mathematics. It motivates people to take impossible dreams and turn them into plans, prototypes, and eventually real missions. Even today, movies, books, and games about space encourage the next generation to pursue astronomy, engineering, and exploration. In a way, fiction fuels science, and science proves fiction right. Without these imaginative tales, the history of space travel might have been much slower and less exciting. Fact 10. The Cold War and the space race. By the mid-20th century, space travel had moved from theory and small experiments into the realm of politics and global competition. The Cold War wasn't just about armies and ideologies, it became a contest to dominate the skies and beyond. In 1957, the Soviet Union launched Sputnik, the first artificial satellite. Suddenly the space race was real, and the world was watching. The United States responded with programs like Mercury and Gemini, determined not to fall behind. Space became a symbol of national pride and technological prowess. The competition pushed rapid innovation. Rockets grew larger and more powerful. Humans left Earth's orbit, and perhaps most importantly, it gave humanity the motivation to step into the unknown, not just for science, but for achievement, survival, and pride. Many of the technologies we take for granted today, satellites, GPS, and even modern materials, have roots in this era. The Cold War, in its tension and rivalry, unintentionally fueled humanity's greatest adventure, the journey to the stars. It's a reminder that sometimes, even political competition can push science to incredible heights. Fact 11. Sputnik, the first artificial satellite picture. It's 1957, and humanity has just taken a giant leap. Not with a man on the moon, but with a small, beeping metal ball orbiting the Earth. That was Sputnik, the first artificial satellite launched by the Soviet Union. At just 58 centimeters in diameter and weighing about 83 kilograms, it didn't look impressive. Yet it changed the world forever. For the first time, humans had put something beyond the atmosphere, and it was circling our planet every 96 minutes. People could even hear it as a faint beep on radio receivers, a simple sound, but one that carried enormous meaning. Suddenly, space wasn't an abstract concept. It was tangible, measurable, and reachable. Sputnik also marked the beginning of an era. The Cold War rivalry between the US and the USSR turned space into a new arena for achievement. Suddenly, the sky wasn't just the limit, it was a battleground for science, technology, and prestige. It's hard to overstate the symbolic power of this small satellite. It proved that humans could leave their planet behind, even if just with a metal sphere. Fact 12. The impact of Sputnik on global politics. The launch of Sputnik didn't just excite scientists, it rattled politicians. The United States had believed it was leading in technology, but Sputnik showed the Soviets were ahead. This triggered what historians call the space race, a fierce competition to achieve superiority in space. Suddenly, science and politics were inseparable. Governments poured money into research, education, and rocketry. America created NASA, and schools emphasized math and science to train the next generation of engineers and astronauts. Every launch, every satellite became a political statement. Who was stronger, smarter, and more capable? Sputnik also changed the public's imagination. Suddenly, space was no longer a distant dream. It was a matter of national security, pride, and technological dominance. In a way, politics accelerated human space exploration. Rivalry pushed rapid innovation, laying the foundation for future milestones like human spaceflight, lunar missions, and interplanetary exploration. Fact 13. Laika, the first living creature in orbit. Before humans could venture into space, scientists had to test whether living beings could survive the harsh environment. That's where Laika, a small stray dog from Moscow, became a pioneer in 1957. Laika was the first living creature to orbit the Earth aboard Sputnik 2, marking a somber but vital step in space exploration. Her journey demonstrated that living organisms could survive launch, weightlessness, and the vacuum of space, at least for a short time. Unfortunately, technology at the time couldn't bring her back safely, but her mission provided crucial data for the development of life support systems that would later keep human astronauts alive. Laika became a symbol of courage and the unknown. Her story reminds us that space exploration has always involved risk, sacrifice, and the pursuit of knowledge, sometimes at great cost. Today, she's remembered as one of the first pioneers to truly orbit the planet, paving the way for human spaceflight. Fact 14. Yuri Gagarin, the first human in space. Fast forward to 1961. The first living being to orbit Earth was a dog, but now it was humanity's turn. Enter Yuri Gagarin, a Soviet pilot who made history by becoming the first human in space aboard Vostok 1. Gagarin's flight lasted just 108 minutes, but those minutes changed how we saw ourselves in the universe. From space, he reportedly said, "I see Earth. It is beautiful." For the first time, a human could witness our planet as a small, fragile sphere suspended in the cosmos. The feat inspired millions around the world, showing that humans could leave their planet behind, if only for a short journey. Gagarin's mission also fueled the space race. The United States felt the pressure to catch up, leading to a rapid acceleration in astronaut training, rocket development, and ultimately the moon missions. Yuri Gagarin became not just a hero, but a symbol of human potential and curiosity. Fact 15. Alan Shepard, America's first astronaut. The US finally responded to Gagarin's orbit with its own astronaut program. In 1961, Alan Shepard became the first American in space aboard Freedom 7. Unlike Gagarin, Shepard's flight was suborbital. It didn't circle the Earth, but it was still a historic milestone for the United States. Shepard's 15-minute flight proved that humans could survive space travel and return safely. He experienced weightlessness, tested controls, and set the stage for longer orbital missions. For the American public, his journey represented hope, ingenuity, and a chance to reclaim prestige in the growing space race. Shepard later became one of the few astronauts to walk on the moon during Apollo 14, but his first flight remains a critical step in human space exploration. It proved that space wasn't just a Soviet achievement, it was within reach for anyone willing to dream, train, and take the risk. Fact 16. the Mercury program milestones. After Alan Shepard's suborbital flight, the United States knew it needed a sustained plan to catch up in the space race. That plan became the Mercury program, America's first human spaceflight project. The goal was simple, but ambitious: send humans into orbit and bring them back safely. Between 1958 and 1963, 6 manned missions carried astronauts into space. Each flight built on the last, testing spacecraft systems, life support equipment, and human endurance in zero gravity. The program wasn't about fancy tricks. It was about proving that humans could survive spaceflight repeatedly. One of the major milestones was Mercury Atlas 6, which made John Glenn the first American to orbit the Earth, a fact we'll touch on more later. The Mercury program also helped NASA learn critical lessons about spacecraft design, launch protocols, and astronaut training. It was the foundation upon which future programs like Gemini and Apollo would be built. The Mercury astronauts became instant heroes. Their courage inspired a nation, proving that spaceflight was not just a dream. It could be done step by step, carefully and scientifically. In many ways, Mercury was the bridge between the first daring suborbital flights and the ambitious lunar missions that would follow. Fact 17. The Gemini program and spacewalks. Once Mercury proved humans could survive orbit, NASA needed a program to prepare for the Moon. Enter Gemini, running from 1965 to 1966. Gemini wasn't about firsts like Mercury. It was about mastering the skills needed for Apollo. One key focus was spacewalks, also known as extravehicular activity, EVA. Astronauts practiced leaving their spacecraft in orbit to perform tasks, a critical skill for future moon missions. Gemini astronauts also practiced docking maneuvers, testing how 2 spacecraft could meet and connect in orbit, which would later be crucial for the lunar landings. Gemini missions also tested longer duration flights, proving humans could live and work in space for days or weeks. These missions weren't glamorous like the first orbital flights, but they were essential. Without Gemini, the Apollo missions might have faced catastrophic challenges. The program also allowed NASA to experiment with new spacecraft systems, navigation techniques, and emergency procedures. In short, Gemini was the behind-the-scenes workhorse, giving astronauts the experience they needed to reach the Moon safely. Fact 18. John Glenn, first American to orbit Earth. No discussion of early spaceflight is complete without John Glenn, who became the first American to orbit Earth on Mercury Atlas 6 in 1962. Glenn's mission lasted just under 5 hours, but those hours were monumental. As he orbited the planet 3 times, Glenn tested spacecraft systems, observed Earth from space, and proved that humans could endure the stress of orbital flight. His calm, confident demeanor inspired both engineers and the public alike. The mission also demonstrated that America could compete with the Soviets, who had already sent Yuri Gagarin into orbit the previous year. Glenn's flight helped NASA refine life support systems, navigation controls, and re-entry procedures. He wasn't just a pilot. He was a pioneer, proving that space wasn't just a foreign dream. It was within humanity's grasp. His orbit marked the United States' true entry into human space exploration. Fact 19. The Apollo program vision. With Mercury and Gemini paving the way, NASA set its sights on the Moon. The Apollo program, officially launched in 1961, had a bold vision: land humans on the Moon and return them safely to Earth. It was audacious, risky, and inspiring, a goal that pushed science, engineering, and human determination to their limits. Apollo wasn't just about sending astronauts to another celestial body. It was about proving humanity could travel beyond its home planet, survive in a completely alien environment, and return with knowledge, samples, and experience. Every spacecraft, rocket, and mission in the program was designed around this single, overarching goal. Apollo also captured the imagination of the world. People watched launches on television, followed training exercises, and dreamed about walking on another world. It wasn't just a scientific mission, it was a cultural phenomenon, a testament to what humans could achieve when ambition met innovation. Fact 20. Apollo 11. Humanity lands on the Moon. Then came Apollo 11, the crown jewel of the space race. On July 19, 1969, Neil Armstrong, Buzz Aldrin, and Michael Collins launched from Kennedy Space Center aboard the Saturn V rocket. 4 days later, Armstrong and Aldrin descended to the moon's surface in the lunar module. When Armstrong stepped onto the lunar surface, he uttered words that would echo through history, a simple statement about a giant leap for humanity. For the first time, humans had set foot on another world. The astronauts collected samples, took photographs, and conducted experiments, all while millions of people watched in awe from Earth. Apollo 11 proved that decades of dreaming, calculations, experiments, and training could culminate in a real, tangible achievement. It wasn't just a victory in the Cold War, it was a victory for curiosity, courage, and the human spirit. Humanity had reached beyond its cradle and touched the moon, forever changing how we see our place in the cosmos. Fact 21. Lunar Module Design and Challenges. When NASA decided to land humans on the moon, engineers faced one of the toughest design challenges in history, building the lunar module. Unlike the Apollo Command module, which orbited Earth and the moon, the lunar module had to land on the moon, support astronauts in a low-gravity environment, and then launch them back to rejoin the orbiting spacecraft. The LM was unlike any vehicle on Earth. It had 2 stages, a descent stage with landing legs and engines to touch down gently on the lunar surface, and an ascent stage to blast the astronauts back into orbit. Every component had to be lightweight yet strong enough to survive launch, landing, and takeoff. Engineers used new alloys, innovative fuel systems, and intricate guidance computers that, compared to modern technology, were astonishingly primitive yet effective. Designing the LM also meant preparing for unknowns. How would it handle moon dust, which is fine and sticky? What if the surface was uneven or sloped? What if the engines failed mid-landing? NASA ran countless simulations and tests, but nothing could perfectly replicate the moon's conditions. The challenges were enormous, but solving them became a testament to human ingenuity and problem-solving. Without the lunar module, the moon landings wouldn't have been possible. Fact 22. Neil Armstrong's historic first step, July 1969. Millions around the world held their breath as Neil Armstrong descended the ladder of the lunar module. The moment he set foot on the moon, he spoke words that would echo through history. His first step wasn't just physical, it was symbolic. Humanity had left its cradle and touched another world. Armstrong's step represented decades of dreaming, calculations, and training. It was the culmination of Mercury, Gemini, and Apollo missions, the work of thousands of engineers, scientists, and astronauts. He carefully tested the surface with each step, noting the consistency of the moon dust and the way low gravity affected movement. The first step was also emotional. Armstrong later described a mixture of awe, responsibility, and humility. He was aware that millions were watching and that every detail mattered. That single moment reminded humans of what was possible when courage met preparation. It wasn't just Armstrong's achievement, it was humanity's. Fact 23. Buzz Aldrin and the moonwalk experience. While Armstrong took the historic first step, Buzz Aldrin soon joined him on the lunar surface. Walking on the moon was unlike anything astronauts had practiced on Earth. The reduced gravity made movement awkward at first, requiring a hopping gait instead of a normal walk. Every step had to be deliberate, every handhold carefully chosen. Aldrin described the experience as both thrilling and surreal. He and Armstrong explored the lunar surface, planted the US flag, and conducted experiments designed to measure the moon's properties. They took hundreds of photographs, capturing details of craters, rocks, and the vast, barren landscape. The moonwalk wasn't just a demonstration of human presence, it was an active scientific mission. Aldrin collected data, tested equipment, and observed conditions that would inform future missions. It was hard, dangerous, and exhilarating, and it gave the world a vivid glimpse of what it's like to set foot on another celestial body. Fact 24. Moon rocks and scientific discoveries. One of the greatest achievements of the Apollo missions was the collection of moon rocks. Astronauts brought back over 380 kilograms of lunar material, which has been studied by scientists ever since. These rocks revealed crucial information about the moon's formation, its geological history, and even clues about the early solar system. Analysis showed that the moon's rocks were older than most rocks on Earth, and contained unique elements not commonly found here. Scientists discovered evidence of volcanic activity, meteorite impacts, and the composition of the lunar crust. These findings changed how we understand not only the Moon, but also Earth's own history. Moon rocks also became symbols of human achievement. They proved that humans could reach another world, study it firsthand, and return with tangible evidence. Even decades later, these samples continue to inspire research and exploration, keeping the spirit of Apollo alive. Fact 25. Apollo 13. Crisis and Survival in Space. Not every mission went smoothly. Apollo 13, launched in 1970, faced a life-threatening crisis when an oxygen tank exploded mid-flight. Suddenly, the mission changed from lunar exploration to survival. The crew and mission control had to improvise solutions to bring the astronauts home safely. Every system was tested under extreme conditions. Oxygen levels dropped, power was limited, and temperatures fluctuated. The astronauts, relying on their training and calm problem-solving, worked with engineers on Earth to improvise repairs, manage resources, and navigate back safely. The safe return of Apollo 13 became a story of human resilience, teamwork, and ingenuity. It showed that even in space, where risks are extreme and mistakes can be fatal, careful planning, quick thinking, and collaboration can save lives. Apollo 13 remains a powerful reminder that space exploration is as much about survival as it is about discovery. Fact 26. Lunar orbiters and mapping the Moon. Before humans ever set foot on the Moon, we needed to understand it better. That's where lunar orbiters came in. These unmanned spacecraft circled the Moon, taking detailed photographs and mapping its surface to help plan safe landing sites for the Apollo missions. The Lunar Orbiter program, starting in 1966, captured thousands of images. Scientists analyzed craters, slopes, and potential hazards. They identified flat areas where the lunar module could land safely and provided critical data on lunar geography. These maps weren't just technical, they shaped the missions that would follow, ensuring astronauts could explore safely and efficiently. Mapping the Moon also allowed scientists to study its geological features in detail. By observing shadows, slopes, and formations from orbit, they could infer the age of craters and the Moon's history of volcanic activity and meteorite impacts. Without these orbiters, the first human landings might have been far riskier. They provided the blueprint for exploration, bridging remote observation and hands-on experience. Fact 27. Apollo 17. The last Moon mission. Apollo 17, launched in 1972, marked the end of humanity's first era on the Moon. It was a historic mission in many ways. It carried the first professional scientist, geologist Harrison Schmitt, to the lunar surface, combining exploration with deep scientific research. Astronauts Eugene Cernan and Schmitt conducted multiple moonwalks, collecting rock samples, setting up experiments, and photographing terrain. Cernan left a final footprint that remains on the Moon, symbolizing the conclusion of the Apollo lunar landings. Apollo 17 demonstrated what humans could achieve on another world, blending adventure, science, and precision. This final mission also reminded the world of the extraordinary human effort behind the Moon landings. Decades of preparation, engineering, and courage culminated in a mission that both celebrated achievement and left a longing for the next era of exploration beyond Earth. Fact 28. The psychology of astronauts on the Moon. Walking on the Moon is thrilling, but it's also psychologically intense. Astronauts faced isolation, pressure, and extreme conditions. The Moon's barren landscape, low gravity, and confined spacecraft could create stress, anxiety, and a sense of detachment from home. Astronauts had to remain calm under high stakes, maintain focus during critical maneuvers, and work effectively as a team. Training prepared them, but the reality of stepping onto another world brought unique mental challenges. Many reported feelings of awe, insignificance, and deep reflection. Understanding the psychological side of space travel was crucial. NASA studied astronaut behavior, communication patterns, and coping mechanisms to ensure missions were safe and productive. This research continues to influence modern spaceflight, especially as we plan for long-duration missions to Mars and beyond. Fact 29. Moon dust and its effects on equipment. Moon dust may look harmless in photos, but it's one of the most challenging elements astronauts had to deal with. The fine, abrasive particles stick to suits, tools, and spacecraft surfaces. They can damage seals, clog mechanisms, and even wear down boots and gloves. During Apollo missions, dust followed astronauts everywhere. It coated their suits, got inside the lunar module, and created unexpected maintenance issues. Engineers quickly realized that lunar dust wasn't just dirt. It was a serious hazard that needed to be controlled for future missions. Despite the challenges, dealing with moon dust provided valuable lessons. It showed that even small environmental factors could have outsized impacts on technology and human activity in space. The experience shaped designs for spacecraft, suits, and equipment that continue to be used in modern exploration. Fact 30. The cultural impact of the moon landing. When humans first set foot on the moon, it wasn't just a scientific milestone, it was a cultural phenomenon. Millions of people around the world watched, inspired by a demonstration of human curiosity and courage. The moon landing reshaped art, literature, music, and popular imagination. It symbolized possibility. Ordinary humans, using ingenuity and determination, could reach the impossible. Children dreamed of becoming astronauts, nations invested in science, and society realized that exploration was more than technology. It was hope and inspiration. The cultural impact continues today. References to the moon landing appear in movies, books, and education. The image of humans walking on another world remains a powerful symbol of what we can achieve when curiosity, preparation, and courage intersect. Fact 31. How rockets escape. Earth's gravity. Imagine trying to jump off a cliff into the sky, but instead of falling, you want to go so high you leave the planet entirely. That's essentially what rockets do when they escape Earth's gravity. Gravity is a constant pull, holding everything, including the air we breathe, firmly on the planet. To break free, rockets need incredible speed and power. This is where Newton's third law of motion comes into play. For every action, there's an equal and opposite reaction. Rockets expel fuel at high speed downward, and that force pushes the rocket upward. The engines must provide enough thrust to overcome not only gravity, but also air resistance as the rocket ascends. The journey is a delicate balance. If the engines produce too little thrust, the rocket will fall back to Earth. Too much, and structural stress can damage the craft. Rocket engineers calculate weight, fuel, and trajectory down to the smallest detail. Every launch is the culmination of physics, engineering, and timing, all working together to let humans and satellites leave our world and reach orbit, or beyond. Fact 32. Saturn V, the giant rocket. When humans decided to land on the moon, they needed something extraordinary. Enter Saturn V, the tallest, heaviest, and most powerful rocket ever built. Standing over 100 meters tall, Saturn V could lift more than 100 tons into orbit. It remains one of the most impressive feats of engineering in history. Saturn V was a multi-stage rocket, meaning it had sections that detached as fuel was spent. This allowed it to shed weight and continue accelerating. Each stage had its own engines and fuel tanks, working in sequence to push astronauts beyond Earth's pull. The rocket's sheer size and power were necessary to carry the Apollo spacecraft all the way to the moon. Watching Saturn V launch was awe-inspiring. The roar of its engines, the plume of flame, and the gradual climb into the sky made it clear humanity had reached a new era. It was more than a machine. It was a symbol of ambition, precision, and human daring. Fact 33. Space shuttle design and reusable spacecraft. In the late 20th century, NASA introduced a revolutionary idea, a reusable spacecraft. The space shuttle combined a rocket and an airplane, designed to launch like a rocket and land like a plane. Unlike Saturn V, which was used once, the shuttle could be refurbished and flown multiple times, making space more accessible. The shuttle carried astronauts, satellites, and even components to build the International Space Station. Its design included wings, a large cargo bay, and a heat-resistant tile system to survive re-entry into Earth's atmosphere. Engineers had to solve incredible problems: how to protect the crew from frictional heat, how to control landing without engines, and how to ensure every system worked reliably on repeated flights. While the shuttle program had its risks, it transformed how humans used space. Reusability reduced costs, increased mission frequency, and allowed astronauts to perform more complex tasks in orbit. It was a bridge between the era of giant rockets and the modern age of commercial spaceflight. Fact 34. Falcon 9 and modern reusable rockets. Fast forward to today, and reusable rockets have reached a new level of sophistication. SpaceX's Falcon 9 can launch satellites and astronauts into orbit, then return its first stage to Earth for another flight. This innovation dramatically lowers costs and accelerates space access. The Falcon 9's engines are powerful and precise, allowing controlled landings on both land and autonomous drone ships at sea. By recovering and refurbishing rockets, companies can reuse expensive hardware, making space missions more sustainable. It's a concept that seemed like science fiction just decades ago, but is now reality. Falcon 9 isn't just a technical marvel. It represents a shift in how humans approach space. No longer are missions limited to government agencies. Private companies can now reach orbit, explore Mars, and even plan space tourism. It's a glimpse into a future where space becomes part of everyday life. Fact 35. Rocket fuel types: liquid versus solid. Not all rocket fuel is created equal. Rockets use either solid or liquid propellants, each with advantages and trade-offs. Solid fuel is stable, easy to store, and can produce high thrust quickly, but it can't be turned off once ignited. Liquid fuel, on the other hand, is more complex but offers control. You can throttle engines, stop, and restart them. Saturn V's massive engines relied on liquid hydrogen and liquid oxygen, offering tremendous efficiency and power. Early military rockets often used solid fuel for reliability and simplicity. Modern rockets, like Falcon 9, use liquid fuel for precision and reusability, combining the best of control and performance. Choosing fuel isn't just technical, it affects every aspect of rocket design, from engine size to weight to safety procedures. Understanding these fuels gives insight into why spaceflight is so challenging, and why every launch is a carefully orchestrated marvel of engineering. Fact 36. Multi-stage rockets and their importance. If you've ever watched a rocket launch, you might notice it shedding sections as it climbs into space. These are multi-stage rockets, a design that allows spacecraft to escape Earth's gravity more efficiently. Each stage contains its own engines and fuel, and as it burns out, it detaches, leaving the rest of the rocket lighter and able to accelerate faster. This concept is crucial because carrying all fuel and structure in a single stage would make the rocket far too heavy. Multi-stage rockets distribute the load and allow engineers to use fuel more efficiently. For example, the Saturn V had 3 stages, each tailored for a part of the journey, leaving Earth, reaching orbit, and heading toward the Moon. Multi-stage rockets also reduce stress on the vehicle and allow for complex missions. Without this design, sending humans or satellites into orbit, or beyond, would be nearly impossible. It's a brilliant solution to a universal problem: how to escape gravity while carrying everything you need. Fact 37. Capsules versus bipedals, spaceplanes. When designing spacecraft, engineers face a fundamental choice: capsules or spaceplanes. Capsules like the Mercury, Gemini, and Apollo spacecraft are simple, robust, and ideal for re-entry. They rely on heat shields to survive the intense heat of returning to Earth. Spaceplanes like the Space Shuttle combine rocket launch with aerodynamic flight, landing like an airplane. Capsules are smaller and more straightforward, making them reliable and easier to produce. Spaceplanes, however, allow astronauts to carry larger payloads, return horizontally, and reuse the vehicle multiple times. Each design has trade-offs. Capsules are safer for deep space missions, while spaceplanes excel at reusable orbital missions. This distinction affects everything from training and safety to mission planning. Modern programs often mix ideas, using capsules for crew transport while exploring spaceplanes for future flexibility. Understanding this choice gives insight into why different missions require different spacecraft. Fact 38. SpaceX Starship, the future of transport. Enter the SpaceX Starship, designed to revolutionize space travel. Unlike traditional rockets, Starship is fully reusable, capable of carrying massive payloads, and intended for missions to the Moon, Mars, and beyond. Its stainless steel exterior, powerful engines, and vertical landing design make it a striking leap forward. Starship isn't just about reaching orbit, it's about making space travel frequent and economical. By reusing the entire vehicle, SpaceX hopes to dramatically reduce costs. It's also designed for humans, with the potential to transport dozens of people to distant planets. This next-generation spacecraft represents the future, a world where space isn't just a dream or a government project, but an accessible frontier for science, industry, and exploration. Starship shows that bold engineering combined with vision can redefine what humans consider possible. Fact 39. Orbital Mechanics Basics. To reach space and stay there, rockets follow the rules of orbital mechanics. Objects in orbit are essentially falling around Earth. If a spacecraft moves fast enough sideways, the curve of its fall matches the curve of the planet, and it stays in orbit instead of falling back. Understanding these mechanics is essential for planning missions. Engineers calculate velocity, altitude, and trajectory to ensure the spacecraft reaches the correct orbit, rendezvouses with stations, or travels to other planets. Even small errors can have huge consequences, which is why precise calculations and careful timing are critical. Orbital mechanics also explains why launches often take curved paths, how satellites maintain their positions, and why re-entry must be carefully timed. It's the invisible choreography that keeps spacecraft moving safely through the vastness of space. Fact 40. The physics of re-entry. Returning to Earth is far from simple. As a spacecraft re-enters the atmosphere, it travels at thousands of kilometers per hour, generating immense friction with the air. This produces heat that can exceed 1,500 degrees Celsius, enough to melt ordinary metal. Heat shields protect the spacecraft by absorbing and dissipating energy. Capsules use ablative materials that slowly burn away, carrying heat with them. Spaceplanes rely on thermal tiles to shield critical surfaces. Engineers must also calculate the angle of a re-entry precisely. Too steep, and the craft could burn up. Too shallow, and it could skip off the atmosphere like a stone on water. Re-entry is a perfect example of how physics governs every step of spaceflight. Without careful design, testing, and understanding of aerodynamics and thermodynamics, returning safely from orbit wouldn't be possible. It's a delicate balance that combines science, engineering, and a little courage. Fact 41. Weightlessness and its effects on the body. Step inside a spacecraft, float off the floor, and you'll experience weightlessness, or microgravity. Astronauts aren't free from gravity completely. They're still pulled toward Earth, but they're in continuous free fall, orbiting the planet. This sensation is exhilarating at first. You can glide across the cabin, flip somersaults, and move effortlessly. However, weightlessness affects the human body in surprising ways. Fluids shift upward, causing puffy faces and nasal congestion. The heart doesn't work as hard to pump blood, which can lead to temporary cardiovascular changes. Even the inner ear, which helps with balance, can feel off, creating motion sickness for the first few days. Long-term exposure changes how the body functions. Muscles weaken, bones lose density, and astronauts need strict exercise routines to maintain strength. Scientists also study how microgravity affects vision, coordination, and even the immune system. Experiencing weightlessness is thrilling, but it also highlights how finely tuned our bodies are for life on Earth. Fact 42. Muscle atrophy in microgravity. One of the biggest challenges of space travel is muscle atrophy. On Earth, muscles constantly fight gravity, keeping us strong. In orbit, this load disappears. Astronauts float effortlessly, and muscles that normally support posture, walk, and even grip don't get the same exercise. Without countermeasures, muscle mass can shrink quickly. Astronauts often lose strength in the legs, back, and core. To combat this, space agencies require daily exercise using resistance machines, stationary bikes, and treadmills adapted for zero gravity. These workouts may seem tedious, but they're essential for maintaining strength for tasks in orbit and for surviving the return to Earth. Muscle atrophy isn't just physical, it affects performance and endurance. Even routine activities, like climbing into a spacecraft seat or moving equipment, become strenuous without proper training and exercise. Understanding and mitigating muscle loss is key for long-duration missions, especially when considering trips to Mars or other distant worlds. Fact 43. Bone density loss in space bones also suffer in microgravity. Without the constant pull of Earth's gravity, bones no longer bear weight, causing bone density loss. Astronauts can lose up to 1 to 2% of bone mass per month, particularly in weight-bearing areas like the spine, hips, and legs. This isn't just a cosmetic issue. Weak bones are more prone to fractures, and astronauts must take special care during and after missions. Exercise with resistance machines, proper nutrition and medications help slow the loss, but it remains a significant challenge for long-term spaceflight. Bone density loss also provides scientists with insight into conditions like osteoporosis on Earth. Studying astronauts' bones helps researchers develop treatments for aging populations or people with limited mobility. In a way, space offers both challenges and lessons that benefit life back home. Fact 44. Space radiation exposure. Beyond physical strain, space poses invisible threats. Radiation exposure is a major concern for astronauts. Unlike Earth, which is protected by the magnetic field and atmosphere, space allows cosmic rays and solar radiation to pass through. Prolonged exposure increases the risk of cancer, damage to the nervous system, and other health problems. Spacecraft and suits provide some protection, but shielding can't block everything. Scientists monitor exposure closely, tracking how radiation affects the body over time. Future missions to Mars or deep space will require even more advanced shielding to protect crews on long journeys. Radiation reminds us that space is an unforgiving environment. Even beyond the thrill of weightlessness or the beauty of Earth from orbit, humans face challenges that require careful planning, advanced technology, and respect for the harsh realities of space. Fact 45. How astronauts sleep in orbit. Sleeping in orbit isn't like sleeping on Earth. Without gravity, astronauts float, and standard beds are useless. Instead, they secure themselves in sleeping bags attached to walls or bunks, preventing them from drifting into equipment or fellow crew members. Microgravity affects sleep cycles too. The sun rises and sets every 90 minutes in low Earth orbit, creating a constant cycle of light and darkness. Astronauts rely on eye masks, schedules, and controlled lighting to maintain a healthy circadian rhythm. Some even use straps or pillows to feel more anchored. Quality sleep is critical. Fatigue can impair judgment, reaction time, and overall performance, which is dangerous in an environment where mistakes can be life-threatening. Sleeping in orbit requires adaptation, planning, and discipline, yet it's also an intimate reminder of the human need for rest, even when orbiting hundreds of kilometers above Earth. Fact 46. Eating and drinking in space. Imagine trying to eat a sandwich that floats away the moment you let go. That's everyday life for astronauts in microgravity. In space, food behaves differently. Crumbs drift, liquids form spheres, and utensils can feel awkward. Special packaging and techniques are essential. Most space food is freeze-dried or vacuum-sealed. Astronauts add water to rehydrate meals, often through a small tube, and sauces come in squeezable packets. Drinks are usually contained in sealed pouches with straws. Gravity won't pull liquids down, so careful preparation prevents spills that could damage equipment or electronics. Eating in space is more than survival. It's also comfort. Astronauts look forward to favorite meals, and shared mealtimes foster camaraderie. Nutrition is critical too. Space food must supply all the calories, vitamins, and minerals needed to maintain muscle, bone, and overall health in microgravity. Despite the odd textures and floating bites, eating in orbit is a mix of science, creativity, and a little fun. Fact 47. Space hygiene and personal care. Living in a confined spacecraft for weeks or months requires careful attention to hygiene. In microgravity, water behaves differently, so showers and sinks as we know them aren't practical. Astronauts use rinseless wipes, no-rinse shampoo, and water carefully contained in small pouches. Toothbrushing, washing, and even going to the bathroom require specialized equipment and procedures to prevent floating debris. Air circulation and filtration help keep the cabin clean, reducing germs and dust. Clothing is also designed to be lightweight, absorbent, and long-lasting, since laundry isn't possible in orbit. Maintaining hygiene isn't just about comfort, it's a critical aspect of health. Good habits prevent infections, maintain morale, and help astronauts feel more normal in an environment that is anything but. It's a constant balance between practicality, safety, and the simple human need to feel clean. Fact 48. Psychological challenges of isolation. Being hundreds of kilometers above Earth isn't just physically demanding, it's psychologically intense. Astronauts face isolation, confinement, and separation from family and friends, often for months at a time. Even the most experienced crew members can feel stress, anxiety, or loneliness. Routine, structured schedules, and communication with mission control help maintain mental health. Astronauts also rely on hobbies, exercise, and personal time to manage stress. Understanding these psychological challenges is crucial for long-duration missions, like trips to Mars, where communication delays make support more difficult. Space agencies carefully select crew members who can handle isolation and work under pressure. They also provide training in conflict resolution and stress management. Even with preparation, the mental aspect of space travel is a constant test of resilience and adaptability. Fact 49. Team dynamics on long missions. Space isn't just about rockets and experiments, it's about people working together in close quarters. Team dynamics are critical for mission success. Crews must cooperate, communicate clearly, and resolve conflicts quickly, as there's no walk-away option. Leadership, trust, and mutual respect become more important than ever. Astronauts spend months in training simulations, practicing problem-solving and decision-making under stress. Long missions amplify personality differences, making emotional intelligence as valuable as technical skill. Positive team dynamics can improve productivity, morale, and safety. Conversely, tension or misunderstandings can escalate quickly, potentially endangering lives. Space agencies carefully monitor interactions and provide psychological support to maintain harmony during challenging missions. Fact 50. Space exercise routines. Microgravity may make floating fun, but it wreaks havoc on muscles and bones. To counteract this, astronauts follow daily exercise routines that are as crucial as eating or sleeping. Equipment like treadmills with harnesses, stationary bikes, and resistance machines help maintain strength and cardiovascular health. Exercise also supports mental health. Physical activity reduces stress, maintains energy levels, and provides structure to long, monotonous days in orbit. Without it, astronauts risk severe muscle atrophy, bone density loss, and even difficulty performing routine tasks. Creating effective routines in space is a challenge. Machines must work in microgravity, fit into confined spaces, and allow for safety while floating. Despite these obstacles, exercise remains a cornerstone of human adaptation to space, ensuring crews remain fit, healthy, and prepared for both their mission and return to Earth. Fact 51. The history of space stations. The idea of humans living and working in space didn't start with the ISS. It goes back decades. Space stations are orbiting laboratories where astronauts can live for extended periods, conduct experiments, and test technologies for future exploration. The concept emerged in the early 20th century, with scientists imagining rotating wheels, modular habitats, and orbital platforms. In practice, the first space stations were launched in the 1970s, giving humans a continuous presence above Earth. These early stations provided crucial lessons about life in microgravity, long-duration missions, and maintaining systems in space. Space stations aren't just science experiments, they're stepping stones for exploring the Moon, Mars, and beyond. They allow astronauts to study the effects of long-term space travel while performing research that benefits life on Earth. From the earliest ideas to today's orbiting laboratories, space stations have been humanity's foothold in space. Fact 52. Salyut and Mir, Russia's early stations. The Soviet Union led the way with Salyut. The first series of space stations launched in the 1970s. These stations were small, single-module platforms designed to test human endurance in orbit and carry out experiments. Crews spent weeks or months aboard, learning how to live, work, and maintain systems far from Earth. Building on Salyut's success, Russia launched Mir in 1986, a modular station that expanded over time. Mir allowed longer stays, more complex research, and international cooperation. It was here that humans began understanding the psychological and physiological challenges of prolonged spaceflight, from muscle loss to teamwork under stress. Salyut and Mir were more than technical achievements. They laid the groundwork for modern international collaboration in space. Lessons learned from these stations directly influenced the design, operations, and research priorities of the International Space Station. Fact 53. Skylab, America's first station. The United States joined the space station era with Skylab, launched in 1973. Unlike Salyut, Skylab was larger and focused heavily on scientific research, from solar observations to materials science experiments. Skylab crews face challenges adapting to life in orbit, including limited space, equipment malfunctions, and the daily tasks of living in microgravity. However, the missions demonstrated that humans could perform sustained work in orbit and paved the way for future international stations. Skylab also gave the US experience in designing life support systems, conducting experiments in microgravity, and managing long-duration missions. Though eventually deorbited, Skylab remains a milestone in American space history. It proved that orbiting laboratories could be more than temporary experiments. They could support science, teamwork, and preparation for the next steps in human exploration. Fact 54. International Space Station, ISS. Overview. The International Space Station is humanity's most ambitious space laboratory, orbiting Earth since 1998. It's a collaborative effort between NASA, Roscosmos, ESA, JAXA, and CSA, combining modules, laboratories, and living quarters into a single orbital platform. The ISS serves many purposes: scientific research, technology testing, education, and international cooperation. It allows experiments that would be impossible on Earth, from studying fluid dynamics in microgravity to observing the effects of long-term spaceflight on the human body. Astronauts from around the world live and work together, demonstrating that space exploration transcends borders. The ISS is also a stepping stone for deeper space missions. Technologies tested here, like life support, energy systems, and modular construction, are essential for future moon bases and missions to Mars. It's a floating hub of science, collaboration, and inspiration. Fact 55. Life aboard the ISS. Living on the ISS is a mix of routine, science, and adaptation. Astronauts float through modules, secure themselves for sleep, and conduct experiments daily. Tasks range from monitoring spacecraft systems to running biology experiments or repairing equipment. Meals are carefully planned and packaged. Hygiene routines require special tools, and exercise is mandatory to maintain muscle and bone health. Crews follow strict schedules to balance work, rest, and personal time, with moments for video calls with family and Earth observation from the windows. Life aboard the ISS highlights both the challenges and wonders of long-term space living. It's a microcosm of humanity in orbit. Teamwork, problem-solving, and curiosity drive everything, all while orbiting our planet at 28,000 kilometers per hour. The ISS is more than a laboratory. It's a home in space that teaches us how humans can live beyond Earth. Fact 56. Scientific experiments in orbit. One of the main reasons we have space stations is science. Orbiting laboratories like the ISS allow experiments that simply aren't possible on Earth. Microgravity affects everything from fluids to combustion, giving scientists unique insights into physics, chemistry, and biology. Astronauts grow plants, study protein crystals, and test how materials behave without gravity. They observe the human body's response to long-term spaceflight, which helps develop medical treatments on Earth. Even something as simple as a flame behaves differently in orbit, offering clues about fire safety and combustion principles. These experiments aren't just theoretical, they lead to practical applications. Pharmaceuticals, water purification, and advanced materials have all benefited from orbital research. By studying phenomena in space, scientists uncover solutions that improve life back on Earth while preparing humans for future exploration of the Moon, Mars, and beyond. Fact 57. The ISS as a global collaboration. The International Space Station is more than a laboratory. It's a symbol of international teamwork. Built and operated by NASA, Roscosmos, ESA, JAXA, and CSA, the ISS combines expertise, resources, and cultures from around the world. Every module, experiment, and mission requires coordination across time zones, languages, and engineering systems. Crews train together, scientists share research, and engineers troubleshoot problems remotely. This collaboration allows ambitious projects that no single nation could achieve alone. The ISS demonstrates that space exploration is a unifying force. Despite political differences on Earth, astronauts and scientists work together daily, proving that curiosity, knowledge, and human ingenuity transcend borders. It's a powerful reminder that when humanity collaborates, we can reach incredible heights, literally. Fact 58. Space Station. Maintenance challenges. Living and working in orbit comes with constant maintenance challenges. Systems for life support, electricity, communications, and experiments must run flawlessly. Even small issues, like a leaking valve or a faulty pump, can affect the entire crew. Astronauts spend hours repairing equipment, replacing components, and monitoring systems. Some tasks require precision while floating in microgravity, using specialized tools and techniques. Engineers on Earth provide guidance, but crews must improvise when immediate solutions are needed. Maintenance is more than fixing broken equipment. It's a matter of survival. Every mission teaches new lessons about durability, redundancy, and adaptability, ensuring that future stations, whether government-run or commercial, are safer and more efficient. Fact 59. Crew rotations and launch schedules. Long-duration missions require careful planning of crew rotations and launches. Astronauts typically stay aboard the ISS for 6 months, though some missions are shorter or longer depending on objectives. New crews arrive via spacecraft like SpaceX's Crew Dragon or Russia's Soyuz, replacing returning astronauts. Timing is critical. Launches depend on orbital mechanics, weather, and vehicle readiness. Crews must train months in advance, rehearsing every procedure, emergency scenario, and experiment. Coordination ensures that operations continue seamlessly, with no gaps in coverage or science. These rotations demonstrate how spaceflight is a continuous endeavour, with human presence maintained around the clock. Each new crew brings fresh energy, new skills, and ongoing research, keeping humanity's orbiting laboratory active and productive. Fact 60. The future of commercial space stations. The era of commercial space stations is just beginning. Companies like Axiom Space and Blue Origin are developing private orbiting platforms for research, tourism, and industry. These stations will complement the ISS, offering more flexible and specialized facilities for science and business. Commercial stations promise more frequent access to space, faster innovation, and opportunities for new industries. Tourists, researchers, and companies could live and work in orbit without government sponsorship. Safety, life support, and maintenance remain challenges, but the lessons from the ISS and past stations provide a solid foundation. The future of space stations is about accessibility and sustainability. Humanity is moving from isolated national projects to an era where space is a shared resource, open to exploration, commerce, and discovery on a global scale. Fact 61. First Spacewalk by Alexei Leonov. Imagine stepping outside your spacecraft while orbiting Earth at 28,000 kilometers per hour. That was the reality for Alexei Leonov, who became the first human to perform a spacewalk on 18 March 1965. Leonov floated into the void outside his Voskhod 2 spacecraft, tethered only by a cord. He spent about 12 minutes outside testing human capabilities in microgravity and learning how to move and work in space. The view was breathtaking. Earth spinning below, the sun casting sharp shadows, but the experience was also terrifying. This historic moment showed the world that humans could survive and operate outside a spacecraft, opening possibilities for repairs, construction, and exploration. It was both a technical achievement and a psychological milestone, proving that humans could adapt to one of the most extreme environments imaginable. Fact 62. Challenges of moving in microgravity. Floating in space may look effortless in movies, but moving in microgravity is surprisingly difficult. Every push or pull sends an astronaut gliding uncontrollably until they encounter a wall or tether. Even simple tasks like grabbing a tool require precision and practice. Astronauts must coordinate movements carefully, using handrails, footholds, and tethers to stabilize themselves. Momentum can work for them or against them. One miscalculated push could send them spinning away from their workspace. Everyday actions, from turning a bolt to adjusting equipment, demand new techniques and patience. Understanding microgravity movement is essential, not only for safety but also for mission success. Every astronaut learns to adapt their instincts, replacing Earth-based habits with methods suited for the unique conditions of orbit. Fact 63. Spacesuit design and safety. A spacesuit is more than clothing. It's a miniature spacecraft. Spacesuits protect astronauts from the vacuum of space, extreme temperatures, radiation, and micrometeoroids. They provide oxygen, pressure, and communication systems, allowing humans to survive and work outside a spacecraft. Suits have layers for insulation, pressure, and abrasion resistance. Gloves are flexible but strong enough to manipulate tools, and helmets have visors to shield from intense sunlight. Life support backpacks supply oxygen and remove carbon dioxide. Safety is critical. A puncture or system failure could be fatal. Spacesuit design has evolved since Leonov's pioneering EVA. Modern suits allow more mobility, comfort, and functionality, enabling longer, safer spacewalks that are essential for repairs, construction, and exploration. Fact 64. Tools for working in space. Astronauts use specialized tools designed for microgravity. Traditional screwdrivers, wrenches, and drills must be adapted to prevent them from floating away or causing damage. Velcro, tethers, and magnetic holders keep tools in place. Some tasks require completely new devices. Cutting, fastening, or measuring in orbit must account for lack of gravity, resistance, and limited mobility in a spacesuit. Engineers spend years designing tools that are lightweight, versatile, and safe for the unique environment of space. Tools are as critical as training. Without them, even simple repairs or experiments could become impossible, showing how every detail of a space mission is carefully planned and engineered. Fact 65. Spacewalking training on Earth. Before stepping outside a spacecraft, astronauts train extensively on Earth. They use neutral buoyancy pools, massive water tanks where divers simulate weightlessness by adjusting buoyancy. Large mock-ups of spacecraft allow them to practice maneuvers, tool handling, and emergency procedures. Training also includes virtual reality simulations, zero-gravity flights in parabolic arcs, and classroom instruction on physics, safety, and problem-solving. Crews rehearse every movement to ensure precision during actual EVAs. This preparation is critical. Spacewalks are unforgiving, and mistakes can be dangerous or fatal. Earth-based training ensures astronauts are ready mentally, physically, and technically, turning what seems like an impossible feat into a manageable, controlled operation in the extreme environment of space. Fact 66. Repair missions on the ISS space isn't forgiving, and the International Space Station is no exception. Despite advanced engineering, components fail, experiments break, and maintenance is constant. That's where repair missions come in. Astronauts venture outside during EVAs to fix solar panels, replace batteries, or install new equipment. One famous example was repairing the Hubble Space Telescope, which required precise work in microgravity. Every repair mission is carefully choreographed, combining astronaut skill, ground control guidance, and specialized tools. These repairs are more than routine maintenance, they're survival. A single malfunction could endanger the crew or jeopardize months of scientific research. Repair missions also showcase human adaptability, proving that even in the harshest environment, ingenuity and preparation can solve complex problems. Fact 67. Tethering and safety protocols. Stepping outside a spacecraft at orbital speeds is exciting but dangerous. Astronauts rely on tethers and strict safety protocols to prevent drifting away. Each astronaut wears a harness connected to the spacecraft or station, ensuring they remain attached during EVAs. Protocols cover every aspect of a spacewalk. Pre-breathing exercises to avoid decompression sickness, tool management to prevent floating hazards, and emergency procedures if something goes wrong. Every movement is deliberate, and every action has redundancy built in. Safety is never optional. Tethers, checklists, and continuous communication with ground control turn risky operations into manageable tasks. They are a reminder that even in space, discipline and preparation are life-saving. Fact 68. Moonwalks versus spacewalks. Walking on the moon is different from floating outside a space station. Moonwalks occur on a surface with about 1/6 of Earth's gravity, while spacewalks happen in true microgravity. The moon's gravity allows astronauts to walk, hop, and carry tools, but they must still adapt to bulky suits and rugged terrain. Spacewalks, in contrast, require floating, careful momentum control and constant tethering. Both environments demand skill, planning, and specialized equipment, but moonwalks add challenges like dust, temperature extremes, and uneven surfaces. Comparing the two highlights how context changes the tasks and strategies for astronauts. Both are feats of engineering, courage, and human adaptability, showing how people can work in environments far removed from Earth's comfort. Fact 69. Famous spacewalk missions. Several spacewalks have become legendary. Alexei Leonov's first EVA in 1965 proved humans could survive outside a spacecraft. Later missions repaired satellites, installed solar panels, and upgraded the ISS. The Hubble Space Telescope missions stand out. Astronauts replaced instruments, corrected optical errors, and extended the telescope's life, allowing it to capture breathtaking images of the universe. Other memorable EVAs include long-duration repairs, emergency fixes, and construction work that expanded human presence in orbit. Each famous mission demonstrates precision, teamwork, and the ability to perform under extreme conditions. They are milestones that showcase how humans can manipulate, build, and repair in the unforgiving environment of space. Fact 70. Future of EVA for Mars missions. As humans plan missions to Mars, EVAs will evolve. Astronauts will work in partial gravity, carry heavier equipment, and face more extreme conditions than low Earth orbit. Suits will need enhanced mobility, dust protection, and life support for longer durations. Training will become even more intensive, possibly including simulations in analog Mars habitats and virtual reality environments. Tools and protocols will adapt to allow astronauts to explore, build, and maintain habitats safely. Future EVAs will combine lessons from past missions with innovative technology, preparing humans for the challenges of walking on alien worlds. They're the bridge between Earth and the next frontier of human exploration. Fact 71. The role of satellites in communication. Satellites have transformed the way humans connect. From TV broadcasts to internet access, communication satellites orbit Earth, relaying signals across continents and oceans. Imagine trying to call someone on another continent without satellites. It would be nearly impossible. Communication satellites are typically placed in geostationary orbit, staying over the same point on Earth. This stability allows antennas to maintain a fixed position, ensuring consistent signals. Messages, phone calls, and data travel from a ground station up to the satellite and back down to another station on the opposite side of the planet. Modern communication relies heavily on satellite networks. They provide internet to remote areas, support disaster relief communications, and enable live broadcasts worldwide. Without them, global connectivity as we know it today, video calls, satellite TV, and GPS-guided systems would be drastically limited. Satellites are silent workhorses above our heads. Though often taken for granted, they are the backbone of modern communication, connecting billions of people across the globe instantly. Fact 72. GPS satellites and navigation. Ever wonder how your phone knows exactly where you are? That's thanks to GPS satellites, a network of orbiting clocks and transmitters. The global positioning system relies on at least 24 satellites circling Earth, each sending precise timing signals. Receivers on the ground calculate distance from multiple satellites using the time it takes for signals to travel. By triangulating these distances, GPS devices determine your exact location, down to a few meters. This technology isn't just for navigation apps, it guides planes, ships, and even emergency responders. GPS has transformed everyday life. It helps drivers find the fastest routes, enables location-based services, and supports scientific research, from tracking animal migrations to mapping Earth's surface. The precision and reliability of GPS satellites make them one of the most important tools in modern society. Fact 73. Weather satellites and Earth monitoring. Weather satellites are like the planet's eyes from above. They observe clouds, storms, temperature changes, and atmospheric patterns, helping scientists predict weather and track climate trends. Satellites in low Earth orbit provide high-resolution images of storm systems, while geostationary satellites monitor large-scale changes over time. Meteorologists use this data to forecast hurricanes, monitor floods, and warn populations of severe weather. Beyond weather, satellites also monitor environmental changes like deforestation, ice melt, and volcanic activity. Earth-observing satellites are essential for disaster management, agricultural planning, and understanding climate change. They allow humanity to see the planet as a whole, providing insights impossible to gather from the ground alone. Fact 74. Hubble Space Telescope discoveries. Launched in April 1990, the Hubble Space Telescope has revolutionized astronomy. Orbiting above Earth's atmosphere, Hubble avoids atmospheric distortion, capturing stunning images of galaxies, nebulae, and distant stars. Hubble has helped measure the universe's expansion rate, revealed black holes at the centers of galaxies, and discovered planets orbiting distant stars. Its deep-field images show thousands of galaxies in what once appeared to be empty space, giving us a glimpse into the universe's vastness and history. Beyond raw science, Hubble has inspired generations with breathtaking images of cosmic beauty. It demonstrates how technology and human curiosity combine to explore the unknown, transforming both our knowledge and our imagination. Fact 75. Voyager missions and interstellar travel. In the 1970s, NASA launched the Voyager 1 and 2 spacecraft to explore the outer planets. These robotic explorers visited Jupiter, Saturn, Uranus, and Neptune, sending back invaluable data and images. Voyager 1 became the first human-made object to enter interstellar space, moving beyond the influence of our Sun. Voyager 2 followed, providing unique insights into the outer reaches of the solar system. Both carry the famous Golden Record, a message from Earth to potential extraterrestrial life. The Voyager missions represent humanity's first steps into interstellar space. They show our desire to explore, learn, and reach beyond the familiar, sending our presence into the cosmos and inspiring dreams of journeys even further into the stars. Fact 76. Mars rovers and exploration. The exploration of Mars has been one of humanity's most ambitious space endeavours. Since the first flybys in the 1960s, robotic rovers have transformed our understanding of the Red Planet. Unlike orbiters, Mars rovers land on the surface, travel across terrain, and conduct experiments directly on the planet's soil and rocks. Early rovers like Sojourner, part of the Mars Pathfinder mission in 1997, were small but groundbreaking. They demonstrated that rovers could move on the Martian surface, analyze rocks, and transmit data back to Earth. These missions tested technology, navigation, and communication systems for future, more advanced rovers. The Spirit and Opportunity rovers took exploration further, spending years traversing deserts, hills, and craters. They discovered evidence of past water activity, altering our understanding of Mars as a once habitable world. Then came Curiosity, a car-sized laboratory capable of analyzing soil, atmosphere, and radiation levels. Curiosity's findings revealed ancient riverbeds, organic molecules, and environmental conditions favorable for life. Today, Perseverance continues this legacy, accompanied by the Ingenuity helicopter, a first in powered flight on another planet. Perseverance searches for signs of past life and collects samples for future return missions, while Ingenuity scouts terrain, proving that aerial exploration on Mars is possible. Mars rovers are more than machines. They are our eyes and hands on a distant world. They test technology, provide scientific insights, and inspire humanity's dream of one day sending humans to Mars. Each mission builds on previous discoveries, preparing for a future where humans may walk across the Martian surface themselves. Fact 77. Probes to asteroids and comets. Asteroids and comets hold secrets from the early solar system. They are remnants of the primordial dust and gas that formed planets, offering a window into the past. Space probes have been sent to study these objects up close, revealing insights impossible from Earth. Missions like Near Shoemaker visited asteroid Eros, mapping its surface and analysing its composition. Japan's Hayabusa and Hayabusa 2 returned samples from asteroids Itokawa and Ryugu, giving scientists physical material to study in laboratories on Earth. These samples help us understand the building blocks of planets and the potential origins of life. Comet missions like Rosetta and its lander Philae studied Comet 67P Churyumov-Gerasimenko. They revealed the structure, chemistry, and activity of comets, showing how solar heating creates jets and dust trails. Such missions also inform planetary defense strategies, helping humanity plan for potential asteroid impacts in the future. By exploring these small bodies, scientists learn about planetary formation, water delivery to Earth, and the chemical ingredients necessary for life. Asteroid and comet probes bridge the gap between distant observation and tangible discovery, expanding our understanding of the solar system. Fact 78. Deep space observation technologies. Observing the universe requires more than looking up with the naked eye. Deep space observation technologies, telescopes, detectors, and sensors allow astronomers to study distant stars, galaxies, and cosmic events. Space-based instruments avoid atmospheric interference, capturing light that would otherwise be blocked or distorted. Telescopes like the Hubble Space Telescope revolutionized astronomy with sharp images and spectral analysis. Modern observatories, such as the James Webb Space Telescope, look into the infrared spectrum, peering through dust clouds and revealing the first galaxies. Ground-based telescopes with adaptive optics also contribute, tracking transient events like supernovae and gravitational waves. Detectors for X-rays, gamma rays, and radio waves reveal phenomena invisible to optical telescopes, from black holes to pulsars. These technologies allow scientists to study the universe across the electromagnetic spectrum, unlocking mysteries of cosmic evolution, dark matter, and exoplanets. Deep space observation is both a technological and human achievement. It combines engineering, physics, and imagination, enabling us to explore the cosmos without leaving Earth, while complementing robotic missions and human spaceflight for a complete picture of the universe. Fact 79. CubeSats and miniaturized satellites. Not all satellites are massive. CubeSats and miniaturized satellites have revolutionized space access by making research, communication, and Earth observation more affordable and flexible. These small satellites often weigh just a few kilograms and can fit into standardized units called U. For example, 1 U is a 10 to 10 x centimeter cube. CubeSats are launched as secondary payloads alongside larger satellites, reducing costs dramatically. They can carry cameras, sensors, or even experimental propulsion systems. Universities, startups, and national agencies use CubeSats for Earth observation, technology testing, and scientific experiments. Despite their size, CubeSats have proven capable. Some have demonstrated interplanetary navigation, swarm communications, and real-time imaging. They allow rapid innovation in space technology, making orbit more accessible to a wider range of organizations and even educational institutions. Miniaturized satellites show that space exploration doesn't always require enormous budgets. They demonstrate creativity, efficiency, and new ways to gather data, bridging the gap between large-scale missions and innovative small-scale experiments. Fact 80. Satellite constellations and internet coverage. Imagine being able to access high-speed internet anywhere on Earth, even in remote deserts or oceans. That's the promise of satellite constellations, networks of hundreds or thousands of small satellites working together to provide global coverage. Companies like SpaceX with Starlink and Amazon with Project Kuiper are deploying these constellations to reduce latency and increase connectivity. Satellites communicate with each other and with ground stations, routing data efficiently around the globe. These networks support communication, navigation, and emergency services, bridging the digital divide in rural or underserved areas. They also demonstrate a shift in space utilization, from isolated satellites serving specific purposes to coordinated systems providing continuous global services. Satellite constellations represent a fusion of technology, engineering, and societal benefit, showing how space infrastructure can directly improve life on Earth while pushing the boundaries of orbital engineering. Fact 81. Past Mars. Missions and discoveries. Humanity's fascination with Mars dates back centuries, but it wasn't until the 20th century that we could send spacecraft to explore it directly. Early missions, like NASA's Mariner program, provided the first close-up images of the Martian surface. Mariners 4, 6, and 7 revealed craters, valleys, and hints of past geological activity, replacing speculation with real data. In the 1970s, the Viking orbiters and landers became the first to successfully land and operate on Mars. Viking 1 and 2 conducted experiments searching for life, analyzed soil chemistry, and captured high-resolution images. These missions showed Mars as a cold, arid world, with evidence of ancient water channels suggesting it might have been habitable long ago. Subsequent orbiters, like Mars Global Surveyor and Mars Odyssey, mapped the planet extensively, identifying minerals, ice deposits, and seasonal changes. Each mission expanded our understanding of Mars' atmosphere, climate, and surface, preparing the ground for future rovers and human exploration. Past missions to Mars transformed our view of the red planet from a mysterious dot in the night sky into a tangible, scientifically rich world, full of history, potential, and questions still waiting to be answered. Fact 82. Rovers, spirit, opportunity, curiosity, perseverance. Rovers have been humanity's boots on the Martian surface. Spirit and Opportunity, launched in 2003, were twin rovers designed to explore different regions and search for evidence of past water. Spirit explored Gusev Crater, while Opportunity ventured across Meridiani Planum, discovering minerals formed in water and dramatic landscapes like Victoria Crater. Curiosity, launched in 2011, is a car-sized mobile laboratory. It drills into rocks, analyzes soil, measures radiation, and studies the atmosphere. Curiosity revealed ancient riverbeds and the presence of organic molecules, strengthening evidence that Mars may have once been habitable. The newest rover, Perseverance, launched in 2020, continues this legacy. It is tasked with collecting samples for future return missions, searching for biosignatures, and testing technology like the Ingenuity helicopter, which demonstrated powered flight on another planet. Each rover builds on the lessons of its predecessors, gradually revealing Mars' history, climate, and potential for life, turning the red planet from a distant curiosity into a well-mapped and deeply studied world. Fact 83. The search for water on Mars. Water is key to life, and finding it on Mars has been a top priority. Early orbiters revealed dry riverbeds, valleys, and sedimentary deposits suggesting that water once flowed across the planet's surface. Spirit, Opportunity, and Curiosity confirm this by analysing rocks containing minerals formed in liquid water. Evidence points to both ancient lakes and seasonal flows. Mars Reconnaissance Orbiter detected recurring slope lineas, dark streaks that may indicate briny liquid water in warmer months. Ice has been found at the poles and just beneath the surface, suggesting that water still exists in frozen form. Understanding Mars' water history is vital for both science and future human missions. Water could support life, provide drinking water, and even be split into hydrogen and oxygen for rocket fuel. The search continues, combining orbiters, rovers, and upcoming missions to piece together Mars' watery past. Fact 84. The challenge of human missions to Mars. Sending humans to Mars is vastly more complex than robotic missions. The journey takes 6 to 9 months one way, exposing astronauts to radiation, microgravity, and isolation. Supplies, life support, and habitat design must be meticulously planned to sustain crews for months or even years. Microgravity causes muscle atrophy and bone loss, while radiation increases cancer risk. Psychological stress from confinement and distance from Earth is another challenge. Safe landing and ascent from Mars's surface add engineering difficulties, requiring advanced propulsion and fuel storage solutions. Despite these challenges, space agencies and private companies are developing plans for crewed Mars missions. Concepts include reusable habitats, in situ resource utilization, like extracting water and fuel from the environment, and robust life support systems. Human exploration of Mars will test endurance, technology, and ingenuity, marking one of the greatest feats in space history. Fact 85. Jupiter. Exploration. Galileo and Juno. Jupiter, the largest planet in our solar system, has fascinated astronomers for centuries. NASA's Galileo spacecraft, launched in 1989, studied Jupiter and its moons for over a decade. It provided insights into Jupiter's massive atmosphere, magnetic field, and volcanic activity on Io, one of its moons. The Juno mission, launched in 2011, continues this exploration with modern technology. Juno orbits in a polar path, studying Jupiter's gravity, magnetic fields, and atmospheric composition. It revealed complex storm systems, unexpected water content, and intricate auroras near the poles. These missions deepen our understanding of gas giants, their formation, and their role in the solar system. Observations of Jupiter also help scientists model other planetary systems, informing the search for exoplanets and the dynamics of distant worlds. Fact 86. Saturn exploration. Cassini and Huygens. Saturn, with its stunning rings and numerous moons, has captivated astronomers for centuries. The Cassini-Huygens mission, launched in 1997, provided an unprecedented look at this gas giant and its system. Cassini orbited Saturn for over 13 years, collecting detailed images, atmospheric data, and measurements of magnetic fields. One of the mission's most remarkable achievemements was deploying the Huygens probe to Titan, Saturn's largest moon. Huygens landed on Titan's surface in 2005, capturing images of rivers, lakes, and dunes composed of hydrocarbons, revealing an eerily Earth-like landscape shaped by methane rather than water. Cassini also studies Saturn's rings, discovering intricate structures, waves, and gaps caused by gravitational interactions with moons. The mission unveiled active geysers on Enceladus, hinting at subsurface oceans that could harbour life. These discoveries expanded our understanding of planetary systems, moon geology, and the potential for habitability beyond Earth. The Cassini-Huygens mission ended in 2017, deliberately plunging Cassini into Saturn's atmosphere to avoid contaminating its moons. Yet its data continues to inspire scientists, revealing the complexity and beauty of Saturn and reminding us how robotic explorers can unlock the secrets of distant worlds. Fact 87. Uranus and Neptune missions. The outer ice giants, Uranus and Neptune, remain some of the least explored planets in our solar system. The only spacecraft to visit them directly was Voyager 2, which flew past Uranus in 1986 and Neptune in 1989. Voyager 2 revealed Uranus's tilted rotation, a blue-green atmosphere rich in methane, and a system of faint rings and moons. Neptune's encounter showed dynamic weather with supersonic winds, massive storms like the Great Dark Spot, and icy moons, each with unique geological features. Though over 3 decades old, Voyager 2's data continues to be analysed, helping scientists understand ice giant formation, atmospheric chemistry, and magnetic fields. Future missions to Uranus and Neptune are being proposed to explore these distant worlds in more detail, as they hold clues about planetary formation and the diversity of planetary systems beyond our own. Exploration of Uranus and Neptune highlights the challenges of reaching distant planets. Long travel times, limited power sources, and harsh conditions require precise planning. Yet the rewards, new knowledge about our solar system's extremes, make these missions essential for a complete understanding of planetary science. Fact 88. Exploring Pluto and dwarf planets. Pluto, once considered the 9th planet, is now recognised as a dwarf planet, but its exploration remains fascinating. NASA's New Horizons mission, launched in 2006, performed a historic flyby in 2014, revealing Pluto's surface in stunning detail. New Horizons showed a diverse landscape with mountains made of ice, vast plains, and a thin nitrogen atmosphere. It revealed unexpected geological activity, suggesting that even small distant worlds can be dynamic. The mission also studied Pluto's largest moon, Charon, uncovering cliffs, valleys, and evidence of past tectonic activity. Beyond Pluto, other dwarf planets in the Kuiper Belt like Eris and Haumea are targets for future exploration. Studying these icy worlds helps scientists understand the solar system's formation, the migration of planets, and the diversity of small celestial bodies orbiting the Sun. Exploration of Pluto and dwarf planets illustrates how even remote, tiny worlds can surprise us, challenging assumptions and expanding our view of the solar system's complexity. Fact 89. Astrobiology and the search for life. Astrobiology is the scientific quest to understand life beyond Earth. It combines biology, chemistry, geology, and astronomy to study conditions that could support life on other planets, moons, and even exoplanets. Mars has been a primary focus, with evidence of past water and organic molecules suggesting it may have been habitable. Moons like Europa and Enceladus contain subsurface oceans, while Titan has liquid methane lakes and complex organic chemistry. These environments are prime targets for astrobiology missions. Astrobiology also guides the design of instruments and missions, from rovers to orbiters, searching for biosignatures, chemical, isotopic, or morphological traces of life. It informs planetary protection protocols to avoid contaminating other worlds with Earth microbes. The search for life is not just about discovery, it challenges humanity's perspective on existence, evolution, and our place in the cosmos. Astrobiology turns every planetary mission into a potential window into life beyond our planet. Fact 90. Future crewed missions to Mars. Human missions to Mars are no longer just science fiction. Space agencies and private companies are developing plans for crewed missions within the coming decades. The journey will take 6 to 9 months one way, requiring life support systems, radiation protection, and sustainable habitats. Technologies under development include in-situ resource utilization, producing water, oxygen, and fuel from Martian soil and atmosphere, advanced propulsion systems, and robust medical support. Astronauts will face challenges like isolation, microgravity effects, and communication delays with Earth. Training for Mars missions is extensive, including analog habitats, simulated surface operations, and emergency drills. Crews will need to operate independently, solve problems creatively, and maintain mental and physical health in a harsh, distant environment. Future Mars missions represent the next great leap in human exploration. They will test the limits of technology, endurance, and cooperation, paving the way for humans to walk on the red planet and eventually establish a sustainable presence, turning dreams of interplanetary exploration into reality. Fact 91. Space tourism and commercial flights. Space tourism has shifted from science fiction to reality in the 21st century. Private companies like Blue Origin, SpaceX, and Virgin Galactic are developing spacecraft to carry civilians on brief journeys to the edge of space. These flights provide passengers with weightlessness, stunning views of Earth, and the experience of crossing the Kármán line, the boundary of space at about 100 kilometers above sea level. Early commercial flights are suborbital, lasting only a few minutes in microgravity. Companies are refining safety, comfort, and accessibility, making space travel more attainable for the general public. For many, these flights are not just thrill rides, they're a chance to see Earth from a perspective few have ever experienced. Space tourism represents a new era of space exploration. It pushes innovation, drives down costs, and inspires public interest in space science. While challenges like safety, radiation exposure, and training remain, commercial flights are the first step toward a future where more people can experience the wonder of space firsthand. Fact 92. Space hotels and orbital resorts. The idea of space hotels has long captured human imagination, and technology is beginning to make it feasible. Companies are planning orbital resorts where guests could experience weightlessness, view Earth from large observation windows, and participate in microgravity activities. Designing a space hotel requires solving unique challenges. Life support, radiation shielding, food storage, and recreation in microgravity must all be carefully engineered. Comfort and safety are paramount, and advanced modular habitats may allow expansion as demand grows. Orbital resorts could serve multiple purposes: tourism, research, and even training for future Mars or lunar missions. They would make space more accessible, turning a brief flight into a prolonged stay, and offering humanity a glimpse of living beyond Earth. Fact 93. Mining asteroids for resources. Asteroids are rich in valuable minerals, metals, and even water ice. Asteroid mining is being explored as a way to supply resources for Earth and support in-space construction and fuel production. Companies envision sending robotic missions to extract metals like platinum, nickel, and iron, as well as water that can be converted into oxygen and hydrogen for fuel. Mining asteroids could reduce the cost of space exploration by providing materials locally rather than launching everything from Earth. It could also advance scientific understanding, as these primitive celestial bodies preserve information about the early solar system. Challenges include precise navigation, robotic extraction in microgravity, and returning resources safely. Yet successful asteroid mining would mark a revolutionary step in humanity's ability to utilize space resources sustainably. Fact 94. Colonizing the Moon. The Moon is humanity's nearest celestial neighbor, making it a prime target for colonization. Plans involve constructing habitats in lunar lava tubes or on the surface, utilizing local materials to reduce reliance on Earth supplies. Water ice at the poles could provide drinking water, oxygen, and fuel. Colonies on the Moon would serve as research stations, testing technologies for long-term living in low gravity, radiation shielding, and sustainable energy systems. They could also act as a launch point for missions to Mars and beyond, providing a stepping stone for deeper space exploration. Moon colonization combines science, engineering, and vision, turning what was once only a dream into a concrete plan for human expansion beyond Earth. It represents the first permanent human presence on another world. Fact 95. Human settlements on Mars. Mars is the ultimate frontier for human settlement. Unlike lunar colonies, Martian habitats must contend with a thin atmosphere, extreme temperatures, and long travel times from Earth. Proposed settlements include pressurized domes, underground bases, and self-sustaining ecosystems using local resources. Water ice, solar energy, and regolith-based construction could support long-term survival. Advanced life support systems would recycle air, water, and waste, while robotics would assist with construction and maintenance. Human settlements on Mars would test technology, adaptability, and resilience, pushing the boundaries of what it means to live on another planet. Establishing a foothold on Mars is more than exploration. It's the beginning of a multiplanetary civilization. Success would redefine humanity's role in the solar system, opening new possibilities for research, innovation, and survival beyond Earth. Fact 96. Advances in propulsion technology. Propelling spacecraft across the vast distances of space is no small feat. Traditional chemical rockets have been the backbone of space travel for decades, but engineers are constantly developing new propulsion technologies to improve speed, efficiency, and safety. Hybrid engines, advanced solid and liquid fuels, and experimental designs like plasma thrusters are making long-distance missions faster and more feasible. Propulsion improvements reduce travel time, lower fuel requirements, and allow spacecraft to carry heavier payloads or humans on extended journeys. These advances are essential, not just for Earth orbit or lunar missions, but for ambitious projects like Mars colonization, asteroid mining, and deep space exploration. Each improvement in propulsion brings humanity closer to exploring farther reaches of the solar system with greater efficiency and reliability. Fact 97. Nuclear and ion. Propulsion in deep space. For deep space missions, conventional rockets may not be enough. Nuclear propulsion offers high energy density, enabling spacecraft to carry less fuel while generating continuous thrust over long periods. Nuclear thermal engines heat propellant using nuclear reactions, providing far more efficiency than chemical rockets. Ion propulsion is another revolutionary technology. It uses electric fields to accelerate ions, producing a steady, low-thrust propulsion ideal for long-duration missions. NASA's Dawn spacecraft successfully used ion engines to visit Vesta and Ceres in the asteroid belt, demonstrating the potential for efficient interplanetary travel. Both nuclear and ion propulsion reduce travel time, expand mission possibilities, and allow spacecraft to reach distant targets that would be otherwise impossible with traditional chemical rockets. These technologies are critical stepping stones towards sustainable exploration of the outer solar system. Fact 98. The role of AI in space exploration. Artificial intelligence, AI, is transforming how we explore space. From autonomous navigation to data analysis, AI systems help spacecraft make decisions in real time, especially when communication delays make Earth-based control impractical. Rovers like Perseverance use AI for hazard avoidance and route planning, allowing them to traverse unpredictable terrain safely. AI also analyzes massive volumes of data from telescopes, satellites, and probes, identifying patterns, anomalies, or potential discoveries faster than humans ever could. In the future, AI will be crucial for long-duration crewed missions. It could monitor life support systems, predict equipment failures, and even assist astronauts with medical emergencies. By combining human intelligence with AI, space exploration becomes safer, faster, and more efficient. Fact 99. International cooperation in space missions. Space has always been a frontier that transcends borders. Many missions are successful because countries collaborate, sharing technology, knowledge, and funding. The International Space Station, ISS, is the prime example, with contributions from the United States, Russia, Europe, Japan, and Canada. International cooperation allows for resource sharing, cost reduction, and the pooling of expertise. Satellites, telescopes, and deep space probes often involve multiple nations, combining strengths in engineering, research, and operations. This collaboration fosters diplomacy and trust while pushing humanity further into space than any single nation could achieve alone. It demonstrates that exploration is a shared human endeavour, highlighting the power of working together to reach new frontiers. Fact 100. The dream of interstellar travel. Finally, the ultimate dream in space exploration is interstellar travel, journeys beyond our solar system to other stars. Distances are immense. Even the nearest star, Proxima Centauri, is over 4 light-years away. Traditional propulsion would take tens of thousands of years to reach it. Scientists and engineers are exploring concepts like fusion propulsion, light sails, and antimatter engines to make interstellar travel feasible. Missions like Breakthrough Starshot propose sending tiny, AI-powered probes to nearby stars at a fraction of the speed of light. While crewed interstellar missions remain in the realm of future possibilities, the dream drives innovation, inspiring new propulsion technologies, energy systems, and AI advancements. It reminds humanity that exploration has no limits, and the stars will always beckon us forward.